Imagine this. You're standing on a hilltop, gazing up at a sky unlike any you've ever seen. A breathtaking tapestry of swirling nebulas, glittering stars, and distant galaxies stretches before you. But unlike the night sky here on Earth, this one holds a profound secret. Countless alien worlds hidden amongst the twinkling starlight. For millennia, humanity has looked to the heavens, pondering this very question. Are we alone in the universe? Are there other planets out there, teeming with life? Or are we truly a solitary speck in the vast cosmic ocean? Well, buckle up, space explorers, because the answer might be closer than ever before. Thanks to incredible advancements in technology, we're finally ushering in a new era of discovery, the era of exoplanet exploration. In this episode, we're going on a captivating journey to explore the latest discoveries in exoplanet research. We'll delve into the fascinating world of these alien planets, uncover the secrets of what makes a world potentially habitable, and explore the cutting-edge science that's helping us peer into the atmospheres of these distant worlds. So, are you ready to join me on this incredible quest? Let's set course for the cosmos and see what wonders await us. What are exoplanets? Exoplanets. These aren't just planets from some sci-fi movie. They're real worlds orbiting stars outside our own solar system. For the longest time, they were just a figment of our imagination, a scientific hypothesis. But then, in the early 1990s, everything changed. Astronomers finally snagged the first glimpse of a true exoplanet. It wasn't quite like the rocky planets we know and love in our solar system, but it was a giant leap for science. This whopper of a planet, a gas giant much larger than Jupiter, was locked in a super-close orbit around a distant star. While it wasn't exactly a candidate for life as we know it, it proved one crucial point. Planets weren't exclusive to our little corner of the galaxy. Since that groundbreaking discovery, the floodgates have opened. New exoplanets are being discovered at an astonishing rate. We're talking thousands confirmed, with countless more waiting to be revealed. It's painting a picture of a universe teeming with an incredible diversity of worlds, some familiar, some fantastical. These exoplanets come in all shapes and sizes. Some are scorching hot gas giants like the first discovery, whipping around their stars in fiery dances. Others are icy giants, lurking in the outer reaches of their systems. But most exciting of all are the smaller, rocky planets. These are the ones that really get our scientific hearts racing. These Earth-sized planets, nestled within the habitable zone of their stars, are where things get interesting. The habitable zone, also known as the Goldilocks zone, is that sweet spot where it's not too hot, not too cold, allowing liquid water to exist on the surface. And as we all know, liquid water is considered essential for life as we understand it. So, the hunt for exoplanets isn't just about finding new worlds. It's about finding another Earth, a world that could potentially harbor life. Could there be another oasis out there teeming with alien biology? The very thought sends shivers down the spine of any space explorer. Techniques to find exoplanets. All right, so we've established that exoplanets are out there, a universe full of them. But how exactly do we find these distant worlds, these cosmic needles in a celestial haystack? Well, astronomers have developed some pretty ingenious techniques to catch a glimpse of these elusive neighbors. Imagine this. You're standing outside on a bright sunny day when suddenly a large object blocks the sun for a brief moment, casting a fleeting shadow. That's the basic idea behind the transit method, one of the most successful techniques for finding exoplanets. When an exoplanet passes directly between its star and us, it blocks a tiny fraction of the star's light. This creates a dip in the star's brightness, which astronomers can detect using incredibly precise telescopes. By measuring the depth and duration of this dip, they can estimate the size and orbital period of the exoplanet. It's like a cosmic game of hide and seek, and every time a planet winks us with its shadow, we learn a little more about it. The universe operates on a delicate dance of gravity. Every object exerts a gravitational pull on everything else around it. This means that even a massive exoplanet orbiting a star will cause that star to wobble ever so slightly. It's like a cosmic tug-of-war. The radial velocity method takes advantage of this wobble. By analyzing the star's spectrum, astronomers can detect these tiny shifts in its light. These shifts tell us how much the star is wobbling, which in turn helps us estimate the mass of the unseen planet causing the wobble. It might be a subtle movement, but with the right tools, we can pick up on these wobbles and infer the presence of a hidden world. The transit and radial velocity methods are the heavy hitters in exoplanet detection, but there are other techniques out there too. Gravitational microlensing, for example, uses the warping of space-time by massive objects to magnify the light of background stars. If an exoplanet passes in front of that background star, it can cause a temporary brightening, another clue hinting at the presence of an unseen world. Astrometry, on the other hand, focuses on the star's position itself. By meticulously tracking the star's movement over time, astronomers can detect tiny wobbles caused by an orbiting exoplanet. It's a more challenging technique, but for massive planets with large orbits, it can be a valuable tool. The beauty of exoplanet research lies in the combination of these different techniques. No single method is perfect, but by using a combination of them, astronomers can build a more complete picture of these distant worlds. It's like piecing together a puzzle, with each observation adding another piece to the picture, revealing the secrets of these fascinating exoplanets. What makes a planet habitable? All right, so we've got these amazing exoplanets out there, but hold on, we're not looking for just any world. We're on a quest to find that special kind of planet, a Goldilocks planet, if you will, that could potentially support life as we know it. So, what exactly makes a planet habitable? Buckle up, because we're about to dive into the recipe for a life-supporting world. At the top of our list is the ever-important liquid water. Life, as we understand it on Earth, relies heavily on this amazing molecule. It's a solvent dissolving essential ingredients for life and facilitating complex chemical reactions. It also regulates temperature and provides a habitat for diverse life forms. This beauty right here represents the habitable zone, also known as the Goldilocks zone. It's the perfect distance range from a star where temperatures are just right for liquid water to exist on a planet's surface. Too close to the star, and you'll end up with a scorching wasteland. Too far, and you'll have a frozen tundra. The habitable zone is that sweet spot where things can get toasty without burning and chilly without freezing, perfect for that liquid water to flow freely. While size isn't everything, it does play a role in planetary habitability. Earth-sized planets are ideal candidates. They're massive enough to hold on to an atmosphere, which is crucial for shielding the surface from harmful radiation and regulating temperature. Imagine a tiny world with a thin atmosphere. It would be constantly bombarded by radiation and wouldn't be able to retain heat effectively, making it a tough place for life to thrive. Gaseous giants like Jupiter and Saturn, on the other hand, might not be the best bets for life as we know it. Their immense size often leads to thick, crushing atmospheres and extreme weather patterns. The building blocks of life are essential too. A planet with a rocky composition is ideal, potentially containing elements like silicon, oxygen, carbon, and hydrogen, the very ingredients that make up organic molecules and life forms here on Earth. Gaseous giants might be lacking in these crucial elements, making them less hospitable for life based on our current understanding. Imagine a world constantly bombarded by harmful radiation from its star. Not a pleasant picture, right? Well, a strong magnetic field acts as a protective shield, deflecting charged particles and radiation from the star. This magnetic shield is like a superhero's cape, safeguarding the planet and making it a more suitable environment for life to emerge. It's important to remember that this is just our current understanding of what makes a planet habitable. Life on Earth is incredibly diverse, and who knows what kind of adaptations might exist out there in the cosmos. Perhaps there are life forms that thrive in environments we wouldn't even consider. But for now, this recipe, liquid water, the Goldilocks zone, a rocky composition, and a magnetic field, is a good starting point in our search for exoplanets that could potentially harbor life. Latest discoveries. The field of exoplanet research is moving at breakneck speed, with new discoveries constantly pushing the boundaries of our knowledge. Let's take a look at some of the most exciting recent finds that are bringing us closer to finding another Earth. 7 Earth-sized planets in the habitable zone. One of the most captivating discoveries came in February 2024. A team of astronomers using NASA's powerful Spitzer Space Telescope identified a system with a whopping 7 Earth-sized planets orbiting a dwarf star just 39 light-years away. The truly jaw-dropping part? 3 of these planets reside within the habitable zone of their star, meaning they could potentially have liquid water on their surfaces. This discovery, published in the scientific journal Nature, has sent shockwaves through the exoplanet community, highlighting the possibility of finding life-supporting worlds closer than ever before. JWST reveals heavy elements in distant gas giant, the James Webb Space Telescope. JWST, the most powerful telescope ever launched, is also making significant contributions. In December 2023, researchers used JWST to analyze the atmosphere of a distant gas giant exoplanet called Smertrios. Surprisingly, they found evidence of heavier elements like oxygen, sodium, and potassium, elements not typically expected in such large gas giants. This discovery challenges our current understanding of how planets form and evolve, and it opens up exciting possibilities for finding even more diverse exoplanets out there. A rare cold exoplanet with a massive companion. In January 2024, astronomers using ground-based telescopes made a rare find: a small, cold exoplanet with a mass and radius between Earth and Neptune. The most intriguing part? This planet has a massive outer companion, hinting at a potentially unusual planetary formation process. Studying this system could provide valuable insights into how different types of planets form and interact within a solar system. TESS spots world with long orbit and cold temperatures. NASA's Transiting Exoplanet Survey Satellite, TESS, is another crucial tool in the exoplanet hunt. In late 2023, TESS identified a new exoplanet with a surprisingly long orbital period. It takes over 1,000 days to circle its star. This world is also thought to have very cold surface temperatures. While this particular planet might not be ideal for life as we know it, studying such extreme exoplanets helps us understand the vast diversity of planetary systems in our universe. The future is bright, unveiling the atmospheres of exoplanets. These are just a taste of the incredible discoveries happening in exoplanet research. The future is even brighter with telescopes like JWST leading the charge. Scientists are now developing techniques to analyze the atmospheres of these distant worlds, searching for biosignatures, chemical signatures that could hint at the presence of life. The possibility of finding another Earth, another cradle of life out there in the cosmos, is no longer science fiction. It's a question of when, not if. We are truly on the cusp of a new era of discovery, and the search for habitable exoplanets is more exciting than ever before. The future of exoplanet research. The future of exoplanet research is nothing short of thrilling. We're on the verge of unlocking unprecedented secrets about the universe and our place within it. Here's a glimpse into what awaits us on this exciting journey. Next-generation telescopes. Powerful telescopes like the James Webb Space Telescope, JWST, are just the beginning. The next generation of space telescopes promises even greater capabilities. Imagine telescopes with incredible resolution, allowing us to directly image exoplanets and see their surfaces in detail. We could potentially even observe weather patterns and geological features, star shades and coronagraphs. One of the biggest challenges in exoplanet research is the glare of the host star. Stars are incredibly bright compared to their orbiting planets, making it difficult to directly observe these faint worlds. This is where innovative technologies like star shades and coronagraphs come in. These are essentially specialized instruments that block out the star's light, allowing us to see the fainter exoplanet next to it. Biosignature hunting. With next-generation telescopes and advanced analysis techniques, scientists will be able to delve deeper into the atmospheres of exoplanets. We'll be hunting for biosignatures, chemical signatures that could potentially indicate the presence of life. These biosignatures might include gases like methane, oxygen, or water vapor, all hints of potential biological activity. Life beyond Earth. Imagine the day we discover a clear biosignature on an exoplanet within the habitable zone. It would be a scientific revolution, completely transforming our understanding of life in the universe. It would no longer be a question of, are we alone? But rather, what kind of life exists out there? The search for second Earths, the hunt for Earth 2.0, a planet with similar conditions to our own, is intensifying. Future telescopes will be able to identify not just Earth-sized planets, but also those with similar atmospheric compositions and potentially even liquid water on their surfaces. Finding a true Earth analog would be a game-changer, pushing the boundaries of astrobiology and igniting our imaginations. Beyond our solar system. The search for exoplanets isn't limited to our sun's neighborhood. Future space missions might explore exoplanets around other stars in different parts of the Milky Way galaxy, or even venture beyond to nearby galaxies. This vast cosmic search will give us a broader picture of how common planetary systems are and the potential diversity of worlds that might exist out there. A universe full of possibilities. The future of exoplanet research is brimming with possibilities. We're on the cusp of a golden age of discovery and the answers to some of humanity's most profound questions. Are we alone? What is our place in the universe? Might be just around the corner. The search for habitable exoplanets is no longer just science fiction. It's a scientific quest with the potential to rewrite our understanding of life and the cosmos itself. So, buckle up, space explorers, because the journey is just beginning. Wow, that was a mind-blowing exploration of exoplanets, wasn't it? The universe is truly a vast and awe-inspiring place, filled with countless mysteries waiting to be unraveled. The search for habitable exoplanets is a thrilling scientific adventure, and we're just at the beginning. But this journey isn't just for scientists, it's for all of us, space explorers at heart. Here's how you can be part of the excitement. Smash that like button. Let me know in the comments below what kind of exoplanet discoveries you're most excited about. Hit that subscribe button. Stay tuned for more cosmic adventures on this channel. And if you enjoyed this video, don't forget to share it with your friends and fellow space enthusiasts. The more we explore together, the closer we get to finding another Earth, another cradle of life out there in the cosmos. Who knows, maybe one day we'll even be able to travel to these distant worlds ourselves. Until next time, keep on gazing at the stars and keep on wondering. The universe is waiting to be discovered. Until next time.